we're going to look at the graph of the other trig functions. What we did last time was the sine and cosine, so we're going to do the secant and cosecant and the tangent and cotangent. We're going to do this at a pretty fundamental level on these. So to begin with, I want to get the graph of the cosecant to start with. All right, so with this, we're going to go ahead and just fill in. I've already filled in the values of the sine. And remember, the sine on the unit circle is just the y values. Okay, so the cosecant's the reciprocal. So we know that the cosecant of an angle theta is 1 over sine theta. So actually, all we're going to do is just do the reciprocals of these values of the sine. You can do all this in your head. So if you do 1 over 0, that would be undefined. Where you have undefined, you're going to end up having vertical asymptotes. And then if you do 1 over 1, that gives 1. And then again, that's undefined. So you're going to find everywhere the sign is 0, you'll end up having a vertical asymptote. So you want to just kind of fill in the sign chart as we go through on this table of values. Reciprocal of -1 is -1, and so forth. Okay, so all I'm doing is just doing the reciprocal of the sine value, and then I'll show you how this graph goes. Okay, and all the information from the sine we learned last week, that's just the y value on a unit circle. So what you want to go ahead and do is get your x-axis set up. So let's see, we have pi over 2, we have pi, 3 pi over 2, 2 pi, and then just do the negatives the same way. Be sure when you get to graphing that you always label, everything on your graph. Label your x and y axis, okay? And let's see, we'll probably go up to about maybe 3 and down to about, say, -3, okay, like that. All right, now what you're going to do on this is we're going to do two things. Actually, everywhere that you see where you are undefined, you want to put a vertical asymptote there, okay? So at -2 pi, you would just sketch in vertical asymptote. At -pi, you have a vertical asymptote. And at x equals 0, in other words, the y-axis is a vertical asymptote. And then you have one at pi, and you have one at 2 pi. Okay, like that. All right, so you always got these asymptotes. The secant and cosecant graph have an infinite number of vertical asymptotes to it. Okay, then what I'll have you do is let's just graph the sine wave. Okay, and you want to get to a point where you have the sine wave memorized pretty well. So I'm just going to start at 0, 0, pi over 2, 1. Okay, like that, and then pi 0, and then 3 pi over 2, -1, and so forth. And just use a dashed line because this is not the graph of the cosecant, but you need to get the graph of the sine to figure this out. Okay, and then we'll do the rest of it kind of like this. And then that's how you want to set that up. So basically, when you're doing a cosecant graph, you want to graph the sine that goes along with it, identify the asymptotes, and then here's how the graph goes. I'll show you this maybe on the calculator here in just a second. So the final graph would go like this. What you do is on top of the maximum of that sine, you just kind of draw this U shape, and then it approaches the asymptotes like we've learned. So anytime you approach an asymptote, the graph's either going to go to infinity or -infinity, like that. You do the same thing here on the minimum. You just make the U shape kind of go downward like that. And over here, kind of goes like that and like that. So that would actually be 2 cycles of that graph. So one period would be 1, 2, 3 asymptotes from 0 to 2 pi. You have the shape going up and the shape going down. And it repeats that forever and ever. Okay? So let me show you a couple of things on the graphing calculator. You can do this or just watch this if you want to. Let's see, I need to make sure I'm in radian mode. So actually, the way you would graph this is like this. You would go 1 over sine of x. That's how you would graph a cosecant, like that. And then I'll do the window, just setting up what we have here. I'm going to go, for a minimum, I'm going to go negative 2 pi and maximum 2 pi. Mainly, I just want to show you what happens at the asymptotes. And then the scale would be pi over 2. And let's see, for the y minimum, I'm going to do something like maybe negative 5 to 5 by a scale of 1 like that. Okay, so you don't have to put this in. You can just watch this if you want to. So what you'd end up getting is the same kind of thing that we created. And basically what happens if you were to trace, like for instance, if I picked a number barely to the right of 0, like if I traced at 0.01, that's a little bit to the right, notice you get a real big number. So what's happening, if you do the cosecant of a number slightly bigger than 0, it just goes to infinity. If I trace at a number barely to the left of 0, notice that it'll give you a negative number, a very small number. So that's how the graph of the cosecant behaves, is like that. Okay, does that make sense what I did? Okay, so if you're doing a cosecant, you just base that graph of the sine, and it just ends up having this type of shape like this. Okay, so basically a couple of observations. This graph does not have a minimum value. It goes on forever. Okay, it does not have a maximum value, unlike the sine and cosine. So the range would kind of go like this. The range would be negative infinity until you get to negative 1. Then there would be a gap, and then from 1 to infinity. So the way to write the range in an interval notation is like this. You just say negative infinity to negative 1, and you include negative 1. That's a definite point on the graph. And then union 1 to infinity like that. Okay, the period is 2 pi. Okay, again, the period is defined by 3 asymptotes and the u going up and the u going down. So it's basically, your 5 key points got to go like this. Asymptote, then that, asymptote, that, like that. So you got 1, 2, 3, 4, 5 key points. All of your trig functions kind of have 5 real important points to them then. The amplitude is none, and the reason is because there's no max and there's no min. Okay, what we learned about the amplitude, what we learned was, like on the sine, the amplitude was half the distance from the min to the max. Okay, so since there isn't a min or max, then there's not an amplitude. Okay, all right, so any questions so far about anything? Okay, one of the things you have to do with the asymptotes is you have to be able to name an equation of the asymptotes. So first of all, I'm just going to write down where we're undefined. So notice our asymptotes were at negative 2 pi, negative pi, 0, and so forth. So let's write down this. It's negative 2 pi, negative 1 pi, 0 pi, 1 pi, 2 pi, and then the asymptotes go on forever. Since the graph goes on forever in both directions, you have an infinite number of asymptotes. So the way you have to name the domain is like this. You have to actually write the domain in set builder notation. And let me explain kind of how this goes. So we would have to say what x is not equal to. Now, since we have an infinite number of places that it's not equal to, we have to write a formula. So these numbers right here, what do you call the numbers 0, 1, 2, 3, negative 1, negative 2, negative 3? What's the name for those kind of numbers? Integers, right? Okay. So what we say is x is not equal to, and I think I usually use k pi. It doesn't matter what you use. That's just a variable. And then you say k is an integer. So you have to write that domain that way. You have to write it as a formula. And what this means is, what I tried to highlight in yellow there was the k. The k is varying as an integer, but you always have that pi there. Does that make any sense? So you're going to have to write formulas on a domain on these, or any other way to do that. You can't write that in interval notation, okay? And then, really you'd get the same thing here. The vertical asymptotes, again, just appear at the same places that I just listed. And I'm just having you write that down because you'll see the pattern. And if you write the equation of a vertical asymptote, it would go like this. You would just say x equals k pi, and then k is an integer, okay? And I think we talked about this before. You can use this kind of z symbol. It's like a z with a double bar on it as a symbol for integer like that, okay? A lot of times that's one of the hardest parts of these problems for students is writing that equation of the asymptotes in the domain, but you should be able most of the time to see a pattern in those asymptotes. And then you just have to come up with a formula. It has something to do usually with integers. Sometimes it can be even integers, odd integers. It just sort of varies, okay? All right, is there any question about anything I did so far? Okay, I want to kind of get through the basic graphs first, and then we're going to do a little bit of work with some transformations. This formula right here, you can use this. I always suggest to students that when you write the equation of the vertical asymptotes, try to just list them and see if you can come up with a formula. If you can't, you can always use this formula. So you can just go like this. You can just say x equals an asymptote, and so you can get all kinds of different answers. You could start at pi. I don't care where you start, just a positive asymptote, 1/2 the period. The period is 2 pi, and then k. So you just do an asymptote, whichever one you want to pick, plus 1/2 the period k, and then k is an integer. Now this would give you a slightly different answer than what I gave you, but it's still okay. So if you did this, the 2's would cross out. You would just get x equals pi plus pi k, where k is an integer. So sometimes students like to just use that formula to find the asymptotes, okay? I don't know how my math lab's going to work on this, though. I mean, they probably want a certain answer to that, so on a test, I don't care, though. I mean, you can write, there's kind of a whole bunch of ways you can write that answer, okay? All right, any questions so far? Okay. All right, well, we're going to do the secant. The secant is the same. I mean, it's not much different. So on the next page, let's go ahead and crunch out the secant's graph. And then the harder part of this is when you start doing transformations, so we'll spend a little bit of time on that. Okay, how do you find a cosine on a unit circle? Of course, we'll need to know that for Wednesday. And I'm going to give you a unit circle on this exam. So how do you find a cosine? What do you look at? X value, right? Okay, so what I did is I went ahead and just filled out the table for the cosine. We know the cosine of 0 is 1, cosine of pi over 2 is 0, and so forth, okay? So the secant is the reciprocal of the cosine, okay? So we're going to evaluate, just use that identity. We're going to do the reciprocal of each of these values that I have in the second row. And you can do this in your head. 1 over 1 would be 1. 1 over 0 would be undefined, so you're going to have an asymptote. 1 over -1 is -1, and so forth. The rest of them, it just repeats. 1 over 0 is undefined. 1 over 1's 1. 1 over 0 is undefined. Then -1, undefined, and 1 like that. Okay, so you're just doing the reciprocal. The graph's going to look real similar to the cosecant. So let's go ahead and just put this together the same way that we did. You want to get your x-axis put together. So we have pi over 2, pi, 3 pi over 2, and 2 pi. You want to get all that labeled. And then do your negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi like that. Okay, and then just make the y-axis probably go up to 3 and maybe down to -3 like that, okay? So we're going to do the same approach on this. You want to start by just everywhere you're undefined in my table, you want to put a vertical asymptote. So on the secant, the asymptotes are in a different place. So you'd have one at negative 3 pi over 2. You'd have one at negative pi over 2. And pi over 2. And then 3 pi over 2, like that. Okay? And then what you want to do is just, sketch the cosine wave. So you can just sketch this second row, just do the cosine. Okay, when you start kind of we get past exam 3 and you start working on your graphing, just remember the cosine starts at 0, 1. That's kind of the first point. Then it cycles through these points like this. Okay, when you get that memorized, you can do the cosine and sine graphs real fast and efficiently. Then just go through and do a dashed line, and that is the graph of the cosine. And then you're going to do exactly the same thing, just kind of do those U shapes that set on top of the minimum and max. I kind of think of this as a camel. That's the camel's back, so the U is on top of it and heads towards an asymptote. Okay, and then this one goes like that, and so forth. Okay, so the only difference is where the asymptotes are. Okay, the shape is different. It's really just a cosecant shifted horizontally in one way, or it's phase shifted. We'll begin to talk about phase shift a little bit today. Okay, is there any question about what I did? Okay, so the whole key to doing a secant and cosecant is to just graph the cosine, find the asymptotes, and sketch. The U shape doesn't have to be perfectly accurate. You just sketch that out, make sure it approaches the asymptotes. All this stuff is the same as it was on the cosecant. There isn't a minimum of y. There isn't a maximum. Graph, goes to infinity in both directions. The range, just like the cosecant, would be negative infinity to negative 1. And then from 1 to infinity, like that. Okay, so you just have that gap between negative 1 and 1. All right, the period is still 2 pi. The amplitude, you don't have 1. That's because you don't have a max or a min. And then we'll kind of do the asymptotes like that. Okay? All right, any questions so far? Okay, now let's write down where the secant's undefined, because we want to write the domain and the equations of the asymptotes, which are very similar. So, and we're going to look for a pattern, basically. So, looks like we have negative 3 pi over 2. Then I'm going to write this as negative 1 pi over 2, just to emphasize that 1. Then we have 1 pi over 2. And then we have 3 pi over 2. And then the asymptotes go on forever like that. Okay? So, if you look at this, when you write the formula, what is always there? What's always there is pi over 2, right? What's changing? The 1, 3, negative 1, negative 3. What kind of numbers are 1, 3, 5, 7, negative 1, negative 3, and so forth? Those are odd numbers. They're odd integers. So what you can do is you can write this like this. Okay, just think the pi over 2 is always there. So you write your domain like this. You say set of x, and you say x is not equal to. You can say n pi over 2, k pi over 2, doesn't matter. Okay, and then what you would say is k, you have to state this. I don't have a symbol for odd integer. You have to say it's an odd integer. Now you can go like that if you want to. Okay, like that. Okay, does that make sense? Okay. So when you write the asymptotes, there's going to be a formula that you have to put on that. And then these are all the same. F and H, we've already written where the asymptotes are. So negative 3 pi over 2, negative 1 pi over 2, and so forth. So when we actually write the equation of the vertical asymptotes, we're just going to say x equals, instead of x is not equal to, then we just say k pi over 2. And then we say again, k is an odd integer. Okay, like that. Okay? Does that make sense? The domain, how I'm writing that, the vertical asymptotes, is that okay? Shake your head or something. okay, because that's usually the hardest part of the problem for a lot of students is that, and the graph's not hard to do. But I recommend that when you do this, just write out the asymptotes and see a pattern. You'll almost always see something that's the same there, and then some pattern with the numbers. If the pattern's too hard to figure out, you can use this formula down at the bottom and do the same thing. So I'll show you how the formula could go. You could say, okay, the first positive asymptote is pi over 2. So you just list that. Then you say 1/2 the period, and the period's 2 pi, times k, and then you say k is an integer. Now, if you use this formula, k is always going to be an integer. So you'd basically just get pi over 2 plus pi k, and k is an integer. And by the way, the reason it's half the period is because there's always an asymptote halfway in the middle on these. So you can think of the period starting at an asymptote, ending at an asymptote, but halfway in the middle is another asymptote. So that's the idea. Okay, does that make any sense? Okay, everybody with me okay so far? Okay. All right, so the basic ones aren't too hard to do. We're going to do the transformations, but the key thing on the transformations, once you get down how to do the sine and cosine, then doing the secant and cosecant, really ultimately just you do the sine and cosine, and then the rest of it you sketch after you find the asymptotes, okay? All right, so we're going to go through, I think I'll do a couple of, one of each, just where you have a translation, okay, and show you how to put these together. And your goal on this is not to have to do a table of values unless you feel like it's necessary. You want to try to be able to do the graphing as much as you can in like 1 or 2 steps, okay? All right, so to begin with on this one, we're doing 2 cosecant of pi x. So what we're really going to work with is y equals 2 sine of pi x. So we're going to graph that and just focus on that. Now the amplitude, be careful about that, is not 2, because I'm asking for the amplitude of the cosecant, and you don't have one. Okay, you never have an amplitude on a cosecant or secant. Now the amplitude of the sine certainly is 2, so we'll have to figure that in when we graph the sine. Okay, the formula for the period, we talked about that last week, is 2 pi over omega. Omega is the number in front of x. Okay, so we just work out 2 pi over pi. Pi is omega. The pi's cross out, so you get a period of 2. So every time 2 units goes by, you're going to have a period, of a cycle of that wave. The increment, what I taught you to do on that, is to take the period and divide it by 4. Okay, so if the period is 2, then we do 2 over 4, and 2 over 4 reduces to a half. So what that means is when we graph, we're going to make our x-axis go by a half, and that's where all of our key points are going to be, okay? And what we do here is we're just going to get the x values that we put on the x-axis, and we just count this out. We have 0 and a half, then you go to 2 halves, which is 1, then you go to 3 halves, then you go to 4 halves, which is 2. And the significance of what I just did there is that gives you your 5 key points of your period. So 1, 2, 3, 4, 5. Remember, the period is 2, so you'll have each of your 5 key points there. And then we can do the negatives as well. So those things go on forever and ever like that. Okay, before I do the asymptotes we're just going to do after we do the graphing. So I would just kind of recommend that you graph first before you even worry about where the asymptotes are. Okay, so what we're going to do is we're going to graph y equals sine of pi x. All right, and hold on, that was a 2 sine pi x, right? Okay, so we're just going to focus on that. So what you want to do is do your increment. Okay, so on the x-axis, you want to just count by a half. So we have 1/2, 1, 3 halves, and then 2 like that. And then you want to go ahead and do the negatives. So negative 1/2, negative 1, negative 3 halves, negative 2 like that. And let's see, the amplitude's 2. So it makes a lot of sense to make your y-axis at least go to 2. So I'd probably just make this go up maybe to 5, because you'll want to have enough room to put the U-shapes in there, and then we're all set up and ready to go. Okay? All right. So really all you got to know is this particular problem, we haven't even learned how to do phase shifts yet, so we don't worry about that. So what happens on this is the basic values on a sine wave go like this: 0, 1, 0, -1, over and over and over again like that. So notice on this that if x is equal to 0, then you would get y equals 2 sine of pi times 0. That would be 2 sine of 0, and the sine of 0 is 0, so you would just get 0. Okay, so your first point on this is just going to be right there. Okay, now you don't have to do this number crunching that I'm doing here unless you feel like you need to. To me, once you get 2 points on a sine, then you know where the rest of them go. Okay, now I'm going to go ahead and go to x equals 1/2 because it's good to show you how all this stuff works anyway. So then I would do y equals 2 sine of pi times 1/2. So again, I'm just plugging that in. And see, what's going to happen is that transfers that to pi over 2, and then you can easily get that then. So this is really 2 sine pi over 2. What's the sine of pi over 2 on the unit circle? That's 1, right? Okay, so see, basically you end up getting 2 times 1, so you get 2. So your next point reaches the maximum and goes to 2 like that. Now you don't have to do all this stuff. If you remember that the sine starts at 0, then goes to 1, the only thing that's going to happen, the amplitude is going to change. So where's the next point? It's going to be there, then where? Where does it go here? Down to the minimum at -2 and so forth. So see, if you can get 2 points, then you know the cycle and you're in good shape. So just go ahead and put the rest of the points in. Okay, like this, and then kind of go backwards with this. That would be like one period of the 2 sine pi x. And then the same thing here, just put the rest of your points in following the cycle. And then that will give us the sine wave. So that's how you want to start the problem, is just get the sine wave, okay? So the asymptotes are always at the midpoints. And you don't want to think of it as x-intercepts because, you know, if we had a vertical translation, you don't think of it as x-intercepts. So the midpoint just means halfway between the minimum and max. So that's where your asymptotes are. So what you want to do is go ahead and put your asymptotes through these values. So we have one at -2. We have one at -1. And we have the y-axis is an asymptote. And we have one at 1. And we also have one at 2 like that. Okay, so you can figure out your asymptotes on a cosecant or a secant just after you graph. Okay, and then we got it. Okay, now you go ahead and just all I want you to do is sketch. The rest of it's a sketch. Doesn't have to be perfectly accurate. Just do the U-shapes, making sure that you're showing that they're approaching the vertical asymptotes the right way. And then that would take us through 2 periods of that graph like that. Okay, so that's what your graph looks like. So I essentially just focused on doing 2 sine pi x. You had to do the period, the increment. Whenever you do that increment, that always gives you where those key points are. And to me, that's the whole key to the problem, is if the period changes, figure out those new x values. Okay, does that make any sense, what I've done? Okay, if you follow this, procedure, you should do fine. Now, let's go ahead and just get the equation of the asymptotes. So the asymptotes are at -2, -1, 0, 1, 2, and then you would predict 3 and 4 and so forth like that. So what's the pattern? That's an easy one. It doesn't even have a pi in it, so what's the pattern? It's just integers, right? That's integers. So what you would say is you would say x equals k or n or whatever variable you want. I always use k. I think our my math lab will use n a lot, but who cares? So this would just be k is an integer. There's no pi in this particular one like that then. So that's it. Okay. All right, any questions? Okay, and like any of this, what you want to do in trig is you want to learn how to graph these things by hand, and you can check on your calculator until you're right on this. But you want to get to a point where you can create a graph fairly easily. Okay, well, these aren't too bad because they don't have a phase shift yet, but we'll start on that today. All right, let's do this one. I'm going to do one cosecant and one secant. And we're going to take kind of the same approach on this. So first of all, the amplitude is we don't have one, but the cosine will have an amplitude of 1/2. Okay, the period is, the formula is 2 pi over omega. You just want to make sure you get a positive value. That's the reason why you have absolute value around omega. So again, omega is 2. So we would have 2 pi over 2. So this time in this problem, the period is pi. Okay? Now, the increment's the key. How do you find the increments? Always the same. On every trig function you ever do, it's period over 4, right? Okay, so we want to just take the period and divide by 4. So the period's pi. So that means your x-axis needs to be generated by going by pi over 4. That's what that means, okay? So we just count this out. We'll always start at 0, then we go pi over 4, and then I'm counting by the numerator, so I go 2 pi over 4, which is pi over 2. Then I go to 3 pi over 4, and then finally I go to 4 pi over 4, so I get to pi. And every time you do this, just make sure it worked out the way you thought it would, is the period is pi. So 1, 2, 3, 4, 5 key points got us to pi. Okay, that should always happen. That's why you're dividing by 4. You're just kind of breaking it up into 4 spaces, which is actually 5 values, okay, when you do that then. Okay, so what we're going to do now is let's just go down to the graph, and let's put this together then. So you want to scale your x-axis. Okay, like I put up there, we have pi over 4, then pi over 2. 3 pi over 4, and then pi. Then over here we have negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi like that. All right, now if you look at what we're going to graph, we're actually going to graph y equals 1/2 cosine of 2x minus 2. Now the way I like to get students to do this is like this. What you always want to do is kind of work with this thing right here and then do anything outside of that at the end like that. So you can actually graph this, and then that's going to move everything down too. And what you want to do on this is maybe just start with a couple of points. And I'm going to go ahead and crunch this out. You can bypass this once you practice this a little bit, but if x is 0, you would end up getting y equals 1/2 cosine 2 times 0. I'm not going to worry about the minus 2. I'm not going to do that part yet. So I get y equals 1/2 cosine of 0. So look at my unit circle. What's the cosine of 0? That's the x value, so what is it? That's 1. Okay, so the cosine of 0 is 1. So you just end up having 1/2 times 1, so you get 1/2. Okay, like that. Okay, and then what we're going to do is I'm going to get another value. I'm going to go to x equals pi over 4. So I'm using the values on my x-axis. And usually if you get 2 points, you're good. Okay, so I'm going to do this. Y equals 1/2 cosine of 2x. So I'm doing 2 times pi over 4. Don't worry about the minus 2. We'll deal with that here in just a minute here. Okay, so that's going to be 1/2 cosine, and the 2 over 4 reduces to pi over 2. Okay, look at my unit circle. What's the cosine of pi over 2 on the unit circle? That's 0, right? Okay, so you end up getting 1/2 times 0, so you get 0. Okay, so here's kind of what we have so far. And this is before we do the minus 2. On the y-axis on your graph, it doesn't matter. I'm going to go like 1, 2, 3, probably like that, and then maybe down to -3 like that. Okay, so what I'm going to do, and you can do this all in one step or 2 steps, I'm just going to take these 2 points and lightly put them on there. So we have, when x is 0, we're at a half, and then we're at pi over 4, we're at 0 like that. And what I'm going to do from here is just kind of sketch the rest. So the next one, where's the next point ready to go to? The minimum, right? So what's the minimum going to be? If the max is 1/2, what's the minimum? -1/2. Now this is before we move these points down 2. Okay, so I usually just tell students, just kind of lightly put in this and then move every point down 2. Okay, now you can do this in one step if you want to, because there's really not that much to it. So that would be what I'm working on right now. See, that's what I just got through graphing, was the graph of 1/2 cosine 2x. Okay, and now what I'm going to do is, in my head, I'm just going to move each of these points down 2. So this is a half. That would go to -1/2 and down there. So that's where that point moves to. This point has a y value of 0, move it down to -2. This point, you have -1/2 down to would take you down to -2.5. And then the rest of it's, pretty predictable. That one goes down 2, so it's there. This one goes down 2, so it should match with this one, like that. And then this is what we're going to graph. And then the rest of it, you can just kind of follow the cycle, okay? Because the values keep repeating themselves. Okay, so I just did that in 2 stages, but you can do it in 1 stage if you want to. Okay, so that's what we get then. All right, does that make sense, what I did? Okay, now the way I look at this is, the original value on a cosine is 1. So what I did is I did 1/2 of 1 to get a half, then I took it down 2. And that's what this graph right here is doing, is it's transforming the point by multiplying by half and subtracting 2. So that's what it's doing on those points on the unit circle, okay? All right, now the next thing is, where is the asymptotes? The asymptotes are at the midpoints. So you need to understand what I mean by midpoints. That's just halfway between the min and max. So those places that I highlighted, that's where your asymptotes are going to go. So you just go straight through that midpoint and so forth. Okay, go straight through each of these to get the asymptotes. And then the rest of it, we're just going to draw the shape. Okay, and that's it. So see, all that work on that problem essentially was doing the cosine graph. That's why I was saying, if you learn how to do a secant and cosecant, what it really depends on is how well you understand how to graph a sine or cosine. So then the rest of it, you just sketch in the U-shapes. Okay, just all I'm wanting on that's a sketch, so that I see that you know how it approaches the asymptote, so that would be your final graph like that. Okay? So is there any question about what I did? Now see, this part right here, you can always crunch out like 2 points. And they always go to the unit circle. That if you're getting your x-axis correct, you're always going to end up on the unit circle with that transformation. Okay, so let's see what our asymptote equations are then. So what I usually tell students to do is, before you get the equation, just write down what you have. So we have a vertical asymptote at -3 pi over 4. We have one at -1 pi over 4. We have one at 1 pi over 4. Then we have one at 3 pi over 4 like that. All right, so if you look at this, what's always the same? Pi over 4 is always there, right? What's changing? The number in front of pi. So what kind of number is in front of pi? An odd integer, right, good. Okay, so that means the equation goes like this. You say x equals k pi over 4, and then you have to say that k is an odd integer. I don't have a symbol for odd integer, so you can write it like that if you want to. Okay? Most of the time on the problems you're going to do that. If you list out the asymptotes, the pattern will be pretty easy to see. Usually it's integers, even or odd. That's almost always what it is. And I kind of designed these problems so that they're fairly straightforward, so you don't get into too many weird numbers. Okay? All right, so that'll take us through kind of what you want to do on a secant and cosecant. Is there any question about what I just did on the graphing? Okay. All right, so just kind of follow this procedure when you do this, and you want to try to see that you can do this without having to rely on your calculator. All right, well, let's go ahead and do the tangent and cotangent, the basic graphs, and then we'll break after we do the basic graphs here. So I just want to show you how the basic tangent and basic cotangent goes. All right, so what we're going to do is we're going to crunch out a table of values for the tangent. And remember, the way you do the tangent of theta is it's y over x. Okay, so I'm just going to go to each of these values starting with 0 and crunch these out. Okay, so basically y would be 0, x would be 1, so we know the tangent of 0 is 0. Okay, if you go to pi over 4, you want to do this in your head. Y is square root of 2 over 2. If you divide by x, what do you get? You get 1. Okay, so that's going to be 1. And then when you go to pi over 2, look what happens. Okay, y is 1, x is 0. So what do you get? Undefined, so you get a vertical asymptote. So just like the other graphs we've done, you're going to get a vertical asymptote. And then when you go to 3 pi over 4, which is here, you can do this in your head. That's just y divided by x. So what do you get there? You get -1, right? You're taking a number divided by itself, but it's negative, so you get -1 there. Okay? And then when you go to pi, y is 0, x is -1, so you get 0 like that. Okay, so again, what I'm doing is going around the unit circle and just crunching out y over x. That's how you use the unit circle to find the tangent. Okay, so you're going to kind of have some predictable points then, and then you can do the rest. -45 would take you to this point, so y over x is back to -1. If you go to negative pi over 2, that would be clockwise, so that would be -1 over 0, so you're back to undefined. And then if you go -3 pi over 4, you end up being in quadrant 3, so that would be +1 when you do y over x there, and then -pi would take you to 0 over -1, so it'd be 0. So you kind of see that this cycle keeps repeating itself through these key numbers like this, okay? And what we're going to do with this then is we're just going to go ahead and graph this. So you want to put your look at the table. You go by pi over 4 on a tangent because the period is pi on a tangent. So we just put these on here to get set up. And do the negatives as well. And once we get this set up, I'll show you on the calculator also how this graph goes. Okay, so what you want to do is put your asymptotes. So we found 2 asymptotes. So you have an asymptote at pi over 2. And we also have an asymptote at -pi over 2. Like that. Okay, and then just do the rest of the points. Just, plot the rest of the points. So at -pi, let's see, let's do the y-axis up maybe to 4. That's probably good enough. And then down to -4 like that. So you got the asymptotes. And then just go ahead and start plotting these points. So -pi, 0. -3 pi over 4, 1. And then what's going to happen is the graph goes like this. So it goes through these dots and then it connects and heads towards the vertical asymptote like that. Okay, then you have negative pi over 4, negative 1, 0, 0, pi over 4, 1, and then you sketch the shape like this. So the shape will look like this, approaching the asymptotes like that. Okay, and then that would be one cycle. In between negative pi over 2 and pi over 2 is one period. Then we have 3 pi over 4, negative 1, pi 0, and then that part goes like that. Okay, so that's what the graph of the tangent looks like. If you, like on the graphing calculator on this, it works this way. So if I put in tangent of x, then you'll see basically this shape. Now I have a different scale on my calculator, but that's basically the way that the tangent structure of the graph looks as like that. Okay, you're going to have an infinite number of vertical asymptotes in it. All right, so what is the minimum value of the tangent? Does it have a minimum value or a maximum value? No, it doesn't have any. Okay, so the graph goes on forever, so the range is going to be all real numbers. So basically, it gets infinitely high, infinitely low, so the range we're just going to write is negative infinity to infinity. The period is pi, and again, this goes like this. If you go, I usually think of the period of a tangent starts at an asymptote, so 1, 2, 3, 4, 5 key points. The distance from negative pi over 2 to pi over 2 is pi units. Okay, so the period would be pi. And then the amplitude, we don't have one. It's none because there's no max or min. Okay, so there's no max or min, so therefore you don't have an amplitude. The only thing you're going to have an amplitude on is the sine and cosine. Everything else is going to go to infinity in both directions, the y values do. Okay, and then as far as the asymptotes, they go like this. So we identified two asymptotes. We had 1 pi over 2 and then negative 1 pi over 2. Well, if you extended through this and kept going, so if you went 1, 2, 3, 4, 5, the next one would occur at 3 pi over 2. Okay, so another asymptote's going to occur at 3 pi over 2, then 5 pi over 2, and so forth, okay, like that. Okay, so it's just basically if you extended that graph and kept counting by pi over 4, eventually you get to 3 pi over 2. And if you look at my unit circle, at 3 pi over 2, is the tangent undefined at 3 pi over 2? Yeah, because y over x is undefined. Negative 1 over 0 is undefined. So you're going to be undefined at pi over 2, 3 pi over 2, and odd pi over 2. So we would say the domain is the set of x, and x can't be equal. So how would you write that? In a formula. So it's 1 pi over 2, 3 pi over 2, 5 pi over 2. How would the formula go? K pi over 2, good. And then what kind of number is k? K is an odd integer, good. So k is an odd integer like that. Okay, so that's how that goes. And then the vertical asymptotes, the same thing. The equation of the vertical asymptotes again, the vertical asymptotes are pi over 2, 3 pi over 2, just writing that down to show you. And then the equation would be x equals k pi over 2, where k is, again, an odd integer like that. Okay, and that's it. Now, there is a formula. If you have trouble, I always want you to try to see if you can write that formula yourself. And most of the time, I think you will be able to. So it's a little bit different for a tangent. What you do is you just take the first positive asymptote you find. So in other words, pi over 2 is the first positive asymptote. Then you add the period. The period is pi, k, and then k is an integer. You're always going to have, if you use the formula, k is an integer. So what's happening on this, the reason it's plus the period is because you started an asymptote, and then at the end of the period is another asymptote. The cosecant and secant were half the period because there was an asymptote halfway in the middle. that period then. Okay, so the cosecant that kind of went asymptote, the U-shape, another asymptote, the U-shape going down, another asymptote. This is just an asymptote to start, an asymptote to end. So that's how you can do that formula. Okay. All right, let's just go ahead and do the cotangent while we're on the subject, then we'll take a break because the cotangent's the same basic idea when you get the fundamental graph, and then we'll finish up the second half of class. We'll do the ones that have got transformations in it. All right, so with this one, first of all, the cotangent of an angle theta is x over y, so we're going to go around the unit circle and we just do x over y. Okay, so I'm going to start here. If we start at 0 radians, x is 1, y is 0, so you would have an asymptote at 0. The cotangent graph's going to look a lot like the tangent. There's going to be a couple of differences. Then if you go to pi over 4, well, then x over y would just be, x over y is going to be 1. There, okay. If you go to pi over 2, x is 0, y is 1, so you get 0. If you go to 3 pi over 4, well then that would be, x over y would be negative 1. And then if you go to pi, x over y would be negative 1 over 0, so that would be undefined again like that. Okay, so it's the same idea. You're going to see that these numbers vary from 1, 0, negative 1, and undefined. Okay, that's one period of the cotangent right there then. Okay, so that would be the definition of one period right there. Okay, and then it just follows this like this. By the same logic, you could figure these out. I'm just going backwards. So undefined, negative 1, 0, 1, back to undefined. Okay, like that. Okay, you can crunch them out individually, but that's what you would get. Okay, and then let's set up the graph. And let's see, we'll just set up the x-axis using the numbers that are in my chart. So pi over 4, pi over 2, 3 pi over 4, and pi, and so forth. And then let's make the y-axis maybe go up to something like 4 would be a good thought. Okay, and then we just put the asymptotes and sketch the points then. Okay, so it looks like on this one we have an asymptote at negative pi. We have an asymptote at x equals 0, so that's the y-axis. We have another asymptote at pi. And then just put your points there. So at negative 3 pi over 4, we are at y equals 1, then y equals 0, y equals negative 1. So the graph is going to kind of look like a reflection of the tangent. So it goes like this. Okay, so that would be like one period of the cotangent graph like this, and then just plot the rest of your points. And you'll end up getting another period like that. Okay, so if you compare the tangent to the cotangent, the asymptotes are in a different place, and then it's really just a reflection. You know, the tangent went more like that. Okay, so it's a reflection. All this stuff right here is mostly the same. We don't have a minimum y or a maximum y. The range is all real numbers on a tangent and cotangent. So a tangent and cotangent can take on any value. The period's pi. The amplitude is we don't have one for the same reason on all these problems we've done here today. And then the cotangent's undefined. Well, let's write down what we found. We found 0, 1 pi, negative 1 pi. If you continued, you would find 2 pi. You would be undefined. Then 3 pi, and so forth like that. Okay, so that's the pattern. So what we're going to say on the cotangent is we would say set of x. X is not equal to k pi. There's always a pi in there, see? So we would say k pi, what kind of number is k in this problem? It's an integer, right. So we'd say x is not equal to k pi, where k is an integer. So far, we've always seen it's an integer or it's an odd. Okay, it can vary a little bit. And then the vertical asymptotes are the same way. They occur at integer pi's. So that we would just say x equals k pi, and we would say k is an integer like that. Okay? So that's how that goes. You can always get these fundamental graphs from the unit circle. The unit circle tells you how to determine those basic graphs anyway. All right, and that's what I'm kind of doing as I'm doing each of these graphs then. Okay, any question about what I did with the cotangent? Okay, so just applying the definition, cotangent's x over y, going around the unit circle, that gives you the points in that table, and that'll show you how the structure goes then. Okay? All right, well, let's go ahead and take, and when you do a graph of a tangent and cotangent that's got transformations, I teach this a little bit different than I do the secant and cosecant. The secant and cosecant, the key is to graph the sine and cosine and then sketch the rest. Okay, it's a little bit different approach on a tangent or cotangent. So I've outlined the strategies that I like to teach, and we'll be kind of going through this as we do this then. So first of all, what you want to do on this particular graph, we're doing a tangent, and you've got a 2 and a half and a -1, so there's several things going on in the problem. The way I like to start this problem is just kind of find the period and then find a vertical asymptote on this graph. So let's start by doing the vertical asymptote. So what you do is you set the argument. You got to know what I mean by the argument. The argument is what you're doing the tangent of. It's that piece right there. So you set that equal to a place where the tangent's undefined, okay? Because we're trying to find out where this is undefined. Well, the tangent's undefined at these two places. And again, it's because the tangent's y over x, so it's undefined. So what I'm going to do is just set it equal to pi over 2, or if you want to, you can set it equal to 3 pi over 2. Okay, you can do that separately, and then you can get two asymptotes. Your strategy on a tangent and cotangent is just to find two asymptotes that are next to each other. That's the whole key to the problem. It's not that hard to do. So what we're going to do is take the argument. You want to write down 1/2 x as the argument, and then we want to set that equal to pi over 2. Okay, and solve that equation. So you can multiply both sides by 2. Okay, so you would actually get x equals pi is where the first asymptote is then. Okay, like that. And then we're going to set it equal to 3 pi over 2 and get the next one like that. You could also set it equal to negative pi over 2. You just set it equal to any place where the tangent's undefined. Okay, all right. So I'm going to take that same argument, 1/2 x. Now I'm going to set that equal to 3 pi over 2 and do the same thing. Okay, so multiply both sides by 2. So what you'll end up getting is x equals 3 pi. And once you get two asymptotes, you'll see the pattern. Okay, I've got 1 pi, 3 pi. What do you predict the next one is? 5 pi, exactly. So 1 pi, 3 pi, 5 pi, and so forth, all right? All right, so what we're going to do now is we're going to find the increment and the period. So the period, the formula is pi over omega on a tangent. Okay, it's not 2 pi over omega. The period of a tangent is pi. So omega is 1/2. So what we'll do is pi divided by 1/2. Okay, well that's pi times pi over 1 times 2 over 1. So the period is equal to pi. 2 pi, I'm sorry. So the period's equal to 2 pi. All right? And see, that makes perfectly good sense to me. Isn't it just 2 pi units away from pi and 3 pi? Okay, that's what we would expect to happen, because the period is just the distance between those asymptotes anyway, so you can figure it out that way. Okay, and then the increment, we always just take the period and divide it by 4. Okay, I do that for every trig function. So that gives pi over 2. So that's going to tell you how to do your x-axis. Okay, so we're going to increment the x-axis by pi over 2, and we'll just take this maybe through one cycle. Okay, so I'm going to just count this out as I go. I've got pi over 2, and you can do this in your head. Then you go to 2 pi over 2, which is pi, and then 3 pi over 2. And then when you go to 4 pi over 2, that gets you to 2 pi. Then the next one would be 5 pi over 2, and then 6 pi over 2 gets you all the way to 3 pi. Okay, and I'm just going to do one period on this like that. So when you count out that increment, just count out by the numerator like that. Okay? All right, so what we're going to do next is, well, we have an asymptote at pi. We figured that out at the beginning of the problem. We have another asymptote at 3 pi. Generally, what I have you guys do is graph through one period. Because you can graph one period, then the rest of it's just repetition anyway. And what we're going to do is this. So what we're going to do is we're going to kind of graph y equals tangent of 1/2 x. And just focus on that. Because what you always want to kind of do is work on this inside part right here. And then the 2 and minus 1, you can adjust those numbers as we go through this then, okay? So here's basically the way that I like you to do this then. So just if you can remember this, on a basic tangent graph, because we went through this a couple of pages back, on a basic tangent graph, what you want to remember is you have asymptotes, and then your key y values are -1, 0, and 1. Those are the y values like that. So before we work with that 2 in front of the tangent and the -1, this is all you got to do. Okay, just if you know that you're graphing a tangent, halfway in the middle of the asymptotes, y is 0. To the right, y is at 1, and to the left, you're at -1 like that. That's all you got to remember on that is those key points in the asymptotes have a y value of -1, 0, and 1. Now what you're going to do is you're going to modify those things then. So now we're going to work with 2 tangent 1/2 x minus 1. So we're going to work with the 2 and the -1. Okay, so here's what you do. Let's start with this y value of -1. So if y is -1, we get 2 tangent, or we just do this. We just do 2 times -1 minus 1. Okay, when we go to the y value of 0, we just do 2 times 0 minus 1. And then the y value of 1, we just do 2 times 1 minus 1. Okay? Because see what I did is the y values on tangent of 1/2 x, if you're just looking at this piece right here only, tangent of 1/2 x, then the y values are -1, 0, and 1. So what I'm doing is I'm just adjusting those now. And that will tell you where those points move to, and then you've got everything that you need. Okay? So once you get the asymptotes, you want to modify those points, the y values -1, 0, and 1, because those are the key points. So this would give you -3. So this point right here that starts -1 is going to go down now to -3. So I just put the final dot right there. This one is -1. So that dot right there now moves to -1. And then this one's 2 minus 1 or 1. So that one stays the same. Okay, so then what you would do is you just sketch it in like that. Once you get those points, you got it. Okay, so see this point has a y value of -3. That's y equals -1, and that's y equals 1. That's it. That's how you put it together. Now see, this is a totally different approach on a tangent and cotangent. The key is to find the asymptotes, then modify those key points in between, modify the y values. Okay, well, that's just taking 2 times the y minus 1. That's it. Does that make any sense? Okay, now when I do a tangent or cotangent, this is just the way I teach it, because the easiest thing I've come up with is just to take this approach. Focus on the asymptotes and the 3 points in between, and that gives you one period. Okay, with this one then, let's see. You can check points anytime you want to. I'm not going to spend time on that, but you can. You can plug in basically any of these points on the x-axis into the entire function and see if it's right. Okay, so you can always do that if you want to. So anyway, the asymptotes are at pi, 3 pi, 5 pi, and so forth. So if we gave the domain of this function, we'd just say x, set of x is not equal to k pi, and k would be an odd integer. Okay, so that's how that would go. And then the equation of the vertical asymptote, same idea. It's x equals k pi, where k is basically an odd integer like that. Okay, so everything I've done so far, the pattern is going to be fairly simple on. Okay, if you don't see the pattern, use the formula that I had earlier in the notes. Okay. All right, so let's do the cotangent. The cotangent is slightly different, but the same basic idea is going to be the same. Okay, so we're going to graph y equals 3 cotangent of pi x. So what you got to do is figure out where the cotangent's undefined. The cotangent's undefined at 0 and pi. Okay, so what you do is you set the argument equal to 0 and pi. So we just take pi x equals 0. That gives you an asymptote. Then we set pi x equal to pi. Okay, so easy equations to solve. You can divide by pi. So you end up getting x equals 0 would be one of your vertical asymptotes. That's the first one we're going to use. Then over here, you can divide both sides by pi. So you would get x equals 1. Okay, and by the way, you can tell what the period is now. Okay, what's the distance between those asymptotes? 1, therefore the period's 1. Okay, the period's the distance between the two asymptotes you find then. Okay, so the period, you can either just find the distance between those two, or you can use the formula pi over omega, and omega is pi, so it would be pi over pi, so it would be 1. So your period is equal to 1. Okay? Now the increment, to do the increment, you just take the period and divide it by 4. So what you're going to do on your x-axis is just count by a fourth. Okay? So I found the asymptotes, and that's always done the same on a cotangent. Find the period and the increment, and then we're ready to start putting this thing together then. Okay? All right, so let's do this. Okay, we're going to count by a fourth. So we have 1/4, 2/4, 3/4, and 4/4. You kind of reduce the fractions in your head as you go. So this would be 1/2 and 1. And I'm not going to worry about the negatives on this problem because I'm only going to do one period anyway. Okay? So you want to go ahead and do your asymptotes. We have an asymptote at 0 and 1. So you do vertical asymptote like that, and vertical asymptote at 1. And then we're ready to put this thing together then. All right, now let's see, the y-axis, let's just go maybe up to 5 and down to maybe -5 like that. Okay, so what we're working on is y equals 3 cotangent of pi x. Okay, now here's how we want to do that. Once you find the asymptotes, then you just have to know these things. And you can kind of do this in your head. So halfway in the middle of an asymptote on a cotangent, you have a y value of 0. To the left, you have a y value of 1. And to the right, you have a y value of -1. So you're going to transform those points by tying in that 3. The last problem we did 2 times the y value minus 1. Well, now all we got to do is this. We have y is equal to 1, so now we just do 3 times 1. So that point right there actually just moves up to the 3 now, okay, like that. Then we have y equals 0. So I do 3 times 0, I get 0, so that point's in the same place. And then I have y equals -1. So 3 times -1 is -3. So we've now got our 3 points in the middle of the asymptote, so the rest of it is just sketch the graph. Okay, so it's going to go like that. Doesn't have to be totally accurate. You just mainly want to make sure you have the asymptotes accurate, the 3 points in the middle accurate, the rest of it's a sketch. So that's how that one goes. Okay, all right. So see, it's the same basic idea. And if you forget how I'm doing this, the previous page shows you the steps that you go through. Just follow the steps and you should be fine. Okay. Just one other thing on this problem, the asymptotes. We have an asymptote at 0, 1. Where do you think the next asymptote is? At 2 and 3. So what would be the equation of the vertical asymptote here? It's just what kind of number? It's an integer, right? It would be x equals k, and k would be an integer. Okay, so it's just the asymptotes occur at an integer. All right, and that's it. Okay, it's not that hard to do. But you got to understand this stuff well in order to memorize, to get a handle on how to do this and how to remember how to do this. Okay, unit circle is kind of where all this stuff, all these values come from and everything. Okay, all right. So let's see that.